In 7.4, we will learn to solve two types of differential equations, separable and linear. We'll start by talking about classifying the differential equations. Now, for the purpose of solving differential equations, classifying them as autonomous or non-autonomous is not helpful. Instead, we need to classify each differential equation as either separable or linear. So let me explain what those two things are. Separable equations. An equation is separable if it can be written in the form f of y dy equals g of t dt, which is just a way of saying that you can put the t's and y's on opposite sides of the equal sign. For example, if we look at y prime equals 3ty, and if we write the y prime as dy dt, then we can multiply both sides of the equation by dt to get dy equals 3ty dt. Then at that point, we can get the variables completely separated by dividing both sides of the equation by y, which will give us 1 over y dy equals 3t dt. So this equation is separable. Let's look now at dy dt equals 5t plus y. If I multiply both sides by dt, I get dy equals 5t plus y. I need parentheses, and that's all being multiplied by dt. How am I going to get that y over with the dy? I can't subtract because it's enclosed in the parentheses. So I guess what you might think of doing is distributing that dt into the parentheses. Now I can subtract, which will give me dy minus y dt equals 5t dt. So we've got nothing but t's on the right-hand side, but notice on the left-hand side, we were forced to drag that dt along with us. And no matter what you try doing with this equation, there's not going to be a way to get all the y's on one side and all the t's on the other. So this equation is not separable. Again, that's because we can't get the t's and y's separated. Let's look now at dy dt equals 5t plus ty. If I multiply both sides by dt, I get dy equals 5t plus ty in parentheses dt. And at first glance, it looks like we're going to have the same trouble with this one. But notice that we can factor a t out on the right-hand side. And now, if we divide both sides by 5 plus y, we have in fact separated the variables because we have 1 over 5 plus y dy equals t dt. So this one is separable. The other kind of equation that we'll learn how to solve in this section is the linear equation. And an equation is linear if it can be written in the form y prime plus p of ty equals g of t. And I think that's probably best explained just looking at examples. So I'm going to try to put the equation in this form, and if I can't, it's not linear. If I can, it is linear. So one thing I notice is that on the right-hand side, there should not be any y's. We can only have t's over there. So let me take any term that has a y in it and subtract it from both sides. So I'm going to I guess I'm going to add, because we've got a minus t squared plus y that obviously contains a y, and so it needs to go to the other side with the y's. So at that point I'll have ty prime plus t squared y equals 3t ln of t. So I've achieved my goal of having only t's on the right-hand side. Another thing I notice is that there can't be a coefficient on the y prime. You have to have y prime just all by itself. So let's divide out the t that's multiplying our y prime, and that will give us y prime plus ty equals 3 ln of t. So I have a y prime just by itself. I've got a y, and the only thing that's multiplying the y is stuff with t's. And on the right-hand side, I have only t's. So it's linear. Let's try another one. Let's look at y prime plus ty squared equals 3t. Now, at first glance, that looks pretty good. I've got y prime all by itself. I've got stuff with t's multiplying a y. And on the right-hand side, I have only t's. But this is not actually linear. Can you guess why? It's not linear because the y has an exponent. And in our format for linear differential equations, there cannot be an exponent on the y. Similarly, you wouldn't be allowed to have an exponent on the y prime term either.